Hello friends, today we are going to discuss very important concepts on the divide and conquer is maximum and minimum, finding the max element and min element in the given list of array. Remember that under divide and conquer we have discussed binary search, we have discussed merge sort and quick sort. So this is the last algorithms we are going to discuss, right? So basically what will happen, we are having list of elements, okay? Say we have 15, 5, 3, 20, 8. Like this, right? We need to find out what will be the maximum element in this and what will be the min element in this. So basically what will happen, if you see that list of arrays, we can see that 20 is maximum, and if we look into this, by comparing all the elements, we will find a minimum is 3. Minimum is 3. So we are going to find out this, right? How basically we are going to approach by using divide and conquer to find the max and min, and what is the straightforward approach as you are doing in a brute force technique to find the min and max value, and how it is different from both the case with respect to time complexity. So we are going to discuss examples, algorithms and time complexity. Okay, so next is finding maximum and minimum examples. Right. So what will happen here, friend? Say we have taken the examples 10, 5, 20, 3, 8, 2 and so on. Right. So basically how many number of elements we have? 1, 2, 3, 4, 5, 6. So n is equal to 6. Right. If you have index, say here if you have index 0, 1, 2, 3, 4, 5. Right. At the beginning, if you wanted to compare these all elements one by one, at the beginning, first element we are going to consider as a mean element or max element. Generally what will happen, you would have studied earlier that we will consider first element as a mean element, we will compare with all the elements and we will update the values. Okay, mean is mean, max is max. Okay, so here also first element you are going to consider as a mean element or max element both, as it is mentioned over here. Right, before we are starting with min max simple examples, this is the list of array, number of elements we have, and we have defined it. Mean is equal to array of 0, max is equal to array of 0. It means considering first element as a mean element or max element, right? So in this particular case we are talking about mean is equal to max is equal to a of 0 is 10. 10 we have considered as a min or max. Since we have already considered this element as a min or max, then our for loop will start from next element to last element. Right? So, because we are not going to start with the 10 with the 10. No meaning of comparing same element with the same element. Our tendency is to find out, okay, comparisons between the different elements. Alright? So, after this what will happen, we are going to compare 10 with 5, right? And if 5 is lesser, we will store mean as a 5, and 10 is greater between 10 and 5, so max will be 10 only. Similarly, now we are going to compare next element 5 with 20. Still 5 is the minimum, right? 10 with the 20, now maximum is 20, right? So we are going to update again and again. Next what will happen, we have 5 is the minimum, 20 is the maximum. We are going to compare with 5 with the 3, 3 is minimum, so we are going to update with minimum values. Hence here 20 with 3, 20 will be remain maximum. Now 3 with 8, 3 is minimum, no problem. 20 with 8, 20 is maximum. Now 3 with 2, 2 is minimum. 20 with 2, 20 is maximum. So we are able to find out that 2 is minimum and 20 is maximum. Let us see that. How exactly it is. Look, as I said you that we are starting the array index after 0, means 1, I less than n, I plus plus. If array of I, right, because I starts from 1, next element, is less than mean. Mean we have already considered as a beginning that first value itself is a mean, right? In that case, we are going to update mean is equal to array of I. Right. Similarly, if array of I is greater than max, then you are going to write max is equal to array of I. These things we are going to complete again and again. right? So let us see that. Now we are going to compare this and this. A of I is 5. Is 5 is lesser than mean element is 10? Is 5 is lesser than 10? Yes, it is true. Hence, mean is equal to A of I. And what is the value? It is 5. Similarly, we are going to compare if next element, is it 5 is greater than 10? False. So in this case, max will be remain same. Max is remain 10 only, right? That is A of 0 only. Here A of 1 is minimum. This is what? A of 1, and this is what? A of 0. Now I will increase. I was here, now I came to this location. Okay, now we can check that. Again we are going to complete this set of. So first, if what is new A of I? A of I is 20. Is it 20 is lesser than what is mean element? Mean was 5. Is 20 is lesser than 5? No, false. So in this case, mean is remain 5 only, and that is A of 1 only, right? Similarly, we are going to check if 20 is greater than what is the next max element? Max was 10, that is A of 0. Then here we can see that condition is true. If condition is true, then you are going to update max is equal to 20 is nothing but A of 2, right? That is A of 2, right? So we have already compared, and till here mean is 5 and max is 20. Now I increases, I came to these positions. Now again we are going to compare if what is A of I value? 3. Is 3 is lesser than mean, and what is mean? Is 5. If condition is true, then you are going to update mean is equal to, right? Mean is equal to A of, look, A of 3 is nothing but 3 only. So new mean we got it. Similarly, we are going to compare if is new element A of 3 is greater than 20? No, it is false. Then max is remain 20 only. Max is 20 only. That is A of 2. So as of now, this is mean element, this is max element. Now what will happen? Next, I came to next positions. We are going to compare 8 with 3, right? So 8 is less than 3, false. It means mean is remain same, that is A of 3 is equal to 3 only. And last we are going to second last, we are going to compare again. Is it 8 is greater than maximum element? Till now max element was 20. Yeah. Is it true? No, it is false. It means max is remain same element as a 20. Both condition is false. Then again I increases. I is 5. So we are going to compare if A of 5, that is 2, is less than mean. Mean is 3. Condition is true. Then mean is equal to A of 5, that is 2. Done. And we are going to check with other conditions. If 2 is greater than max, and what is max? Max is 20, that is A of 2. Condition is false. Hence max is remain A of 2, that is 20. Then I will increase. If I increases, it is 6, right? So let us see that what will happen. I will go maximum to I less than n, right? I less than n, but number of element is 6. 6 minus 1 till 5 only, it is true case. Once you have entered in 6, this is false case, and for loop will terminate. So this particular loop is terminated. We came out from this, and we are going to write printf minimum element is mean, maximum element is max. So here we are going to print as a 2 is a minimum element, and maximum element is 20, right? So as per this final, we are going to print 2 is minimum is 2 and maximum is 20, right? So this is what we have applied single for loop. We have applied single for loop and completed the task. Now question is to check with their complexity, right? Since it is non-recursive algorithms, as we have discussed earlier, general plan for mathematical analysis for non-recursive algorithms. In that case, single for loop means you are going to write it summation, right? And we are going to write I is equal to 1 to n. Yes or no? I is equal to 1 to n. Now you can see that we are having one instructions here, one instruction here. We have two instructions, right? Sometimes in a book they will mention that only one, but here we are going to compare 2 times. So hence we have a 2 basic operations. In that case 2 is common. Now we are writing I is equal to 1 to n and here is 1. And finally we are going to say that 2 upper limit is n, lower limit is minus 1 and plus 1. 1 and 1 got cancelled, hence it is 2n. And then you can conclude it, time complexity in this particular case it will be theta of n. Theta of n when you are dealing with simple min-max algorithms without using divide and conquer strategy. Okay, in that case we got time complexity as a 2n. Okay, point to be noted, we are getting proper time complexity as a 2n. If you are applying divide and conquer and we are able to reduce from 2n, then you can say that yes, it is more efficient and more effective. Okay, so let us discuss how we are going to approach in divide and conquer strategy. Remember that as we discussed earlier also, divide and conquer means what? We are dividing the problem into the sub problems and finally we are going to merge solution to the sub problems in order to get the final solutions. No. Remember that divide and conquer strategy says that if you have n element, in this particular examples we had a 6 element, if you are dividing it maybe 3 elements and 3 elements, definitely in these first 3 will be having minimum element, last set of 3 elements will have minimum elements. We find that and compare both the minimum and finally we find the minimum element. Similarly, half of the array will have the maximum element, second half of the array will have another maximum element, right? Compare finally at the max element, we will get the final answer. Now, point to be noted is if you have a single element, only one element, then either that will be, we can say that max element or minimum element, both, because we don't have any other element to compare. So we can say that if L is equal to R, basically it is example. Let us take that example again and see that how exactly we are going to address this. We have 10, 5, 20, 3, 8, 2. 10, 5, 20, 3, 8, 2. N is equal to 6. Right? 0, 1, 2, 3, 4, 5. In this case, what will happen? Look, here we have more elements, but what is that? L is 0 and right index is R is 5. Right? Here code is if L is equal to R. L is equal to R means when we have only one element, say it is just a 5 and L is also pointing to 0 and R is also pointing to 0 only, 0 in the index. Only one element means one index. Then 5 is only your mean element and 5 is only your max element. Okay, there is no contradictions. Same element considered to be the mean element, same element considered to be the max element. Problem is if you have two elements. If you have two elements, then you want to simply do the comparisons as we did it in the previous basic concepts. If A is lesser than B, return A is a minimum. In that case, B is a maximum. Else, A is a maximum, B is a minimum. So same thing you are going to do it here is, else if L is equal to R minus 1, L is equal to R minus 1 means low index is equal to R minus 1. Look, if you have two elements, say as for example we have a 10 and 5, two elements, right? So we can see that 10 is maximum, 5 is the minimum, right? So here if you see that index 0 and 1 is index, 0 is low index, this is R is 1. So condition is if L is equal to R minus 1, 1 minus 1 is 0, right? In that case is fall in this case, not in first case. In that case, if A of L is lesser than A of R, A of L is 0 is lesser than 5, 10 is lesser than 5. Is 10 is lesser than 5? No. If not, then it come in the else part and max is equal to A of L. So max is equal to A of L is 10 and mean is equal to A of R is 5. So in this case, we can see that we got max is 10 and mean is 5, right? If you have other case like say 10, 15, then 15 will be max, 10 will mean. So here we are addressing only single elements, and if you have two elements, we'll do the simple concept and we get the answer that mean is so and so element, max is so and so element. Now, question is when we are having this kind of problem, more number of elements, then it will go in else part. And what we are going to do basically, mid is equal to L plus R divided by 2. In this case, mid is equal to L plus R, 0 plus 5 divided by 2. It is 2. 2.5, it is 2. So 0 to 2 is one array and 3 to 4, 5. Look, max mean function calling itself L to mid. L is 0 to mid is 2. So we got one array is called 10, 5, 20. 10, 5, 20. And second array we have max mean mid plus 1 to R. So we have 3, 8, 2. And here we have mid plus 1, 2 plus 1 is 3, 4, 5. So this is another array, this is first array. We got this. If you are doing so, again we are going to compare. So this is a function calling itself, and once we are done with this, then only it will come in this particular part. So let us see that. Again we will go and compare. Is L is equal to R minus 1. Now L is 0 and R is 2. Here L is 3 and R is 5. Right? So L is equal to R? No. L is not equal to R. L is equal to R minus 1. 2 minus 1 is 1. No, 0 is not equal to 1. Here even 3 is not equal to 4. So fail. Again will come in mid. Calculate the mid in else part. Mid is equal to 0 plus 2 divided by 2 is 1. And here we have mid is equal to 3 plus 5 divided by 2 is 4. Right? Then we are writing here max mean, again function calling itself, and we are dividing this array into two parts. L 10 to 0, 1, 10, 5 is one arrays. And here we have next mid plus 1, 1 plus 1 is 2, right? Here we have 20, right? Similarly, here we have 3 plus 5 divided by 2 is 4. So 3 and 8 is in one array and 2 will go to the last positions. Now, let us see that. Till now we are going to divide the problems. Again we'll go and compare. Is it L is equal to R? L is 0, R is 1. Is L is equal to R? No. Then go in else part. L is equal to R minus 1. L is 0, R is 1, 1 minus 1 is 0. Yes. In that case, A of L is lesser than R, A of L, 10 is lesser than 5. No, it will come in else part. And we are writing here max is equal to A of L is 10, mean is equal to is 5. So here we got max and mean. In this particular case, when L and R is same, right, then this is max and this is max. Max is 20 and mean is 20, both. Done. Similarly here, in this particular case, if you are going to compare A of L with R, right, then we can find that mean is 3 based on this logic, mean is 3 and max is 8. in this particular case, mean is 2, max is 2. This is what we have done it. Alright. Now after that there is a concept. If max is lesser than max r, say this is the max, this is another part is max r, right hand side is max r, mean r. In that case max is equal to max r, okay, and mean is equal to mean r. If max is lesser than max r, max is lesser than max r, yeah, so 10 is lesser than 20, right? In that case max is equal to max r, so max will be 20, max will be 20. If it is true 10 is lesser than 20, max and max are going to compare, and finally you go and find out the maximum element in this. Similarly mean and mean you are going to compare. If mean is lesser than mean r, mean is greater than mean r, then mean is equal to mean r, otherwise mean will be remain same. So mean is 5. We got these two elements from here. Alright. Next, in this particular case, what will happen, friend? We are going to talk 20 and 5. And here we have 3 and 8. In 3, if you are going to compare mean and mean, 2 and 3, final mean is 2. Max and max, final max is 8. Now here we have mean 2, max 8. Okay. Here we have max 20, mean 5. Now you compare max with max. So this is the right side of the array of this particular case. So mean and mean are. Mean is greater than mean r, then mean is equal to mean r. Mean is greater than mean r, 5 is greater than 2. So we can see that 5 is greater than 2, true. So mean is equal to mean r, it is 2. Similarly, in the case of max, 20 and 8, 20 is greater, hence we are going to write max is equal to 20. So finally we are getting in this particular example, right, mean is 2 and max is 20, right? And same answer we got it for previous concepts also. Mean is 2, max is 20. Here only difference is we have applied divide and conquer strategy, right? Now to discuss recursion tree, how to do recursion tree, friend, this is all what we did it, traversing of these algorithms and how to write these algorithms based on this concept, okay, by using divide and conquer strategy. Yes. Now we have two concepts to be discussed. One is time complexity and other is recursion trees. If we are able to discuss that time complexity, what I said, if n is equal to 1, then we are not going to call the function itself, hence it is 0. If n is equal to 2, we have two elements. If you have two elements, then still we are not recursive call we have used, just we have used if else statements, and how many times? 1 and 2 times. So this part we are considering as a, without using recursive call, we are using one instructions, right? Either it will go in this case or it will go in this case. Okay, so let us see that. So n is equal to 2, we have 1. N is greater than 2. In that case, what will happen? 2tn by 2 for dividing the arrays into two parts, left recursions and right recursions. Right? Left recursions and right recursions. And these two is basically for these comparisons. Either you are going to compare this and you are going to assign these values, or you are going to do this part, right, under this recursive call. So whenever you are going to do it, we are doing this part also, we are doing this part also. Hence it is 2tn by 2 plus 2. 2tn by 2 for time taken to perform left side of the arrays, time taken to perform right side of the arrays, and 2 is to perform other operations, right, for n is equal to 0, or if element low index and higher index is same, and low index is higher index minus 1, in that case you are going to use if else statement, and final if else statement to compare left mean with right mean, left max with right max. Once you are done with that, then you remember that this is what? Recurrence relations. So this is called recurrence relations. For any recursive functions, recurrence relation is a must, and we have done this analysis, right? Avoid this. We have done this analysis. Now, when n is a power of 2, right? Why you are going to do? Because it is a division. So we have to stop this recursion after some terms, and we have seen that in previous examples we have stopped it, right? So we have just considered n is equal to 2 power k. Okay, n is equal to 2 power k for simplifications. So let us see that t of n is equal to, when we have t of n is 2t n by 2 plus 2, right? So t of n by 2 becomes 2t n by 2 plus 2, right? 2t n by 2 becomes 2t n by 2 plus 2. This is plus 2 is original. We will compute it. What will happen? 2 square, it is 4t n by, here, n by 2 divide by 2, it is nothing but n by 4 plus 2 into 2, it is 4 plus 2. So same thing, it is been written that 2t n by 4 plus 2, 2 and 2 is multiply, it is 4 plus 2, right? Now, if we go to the next iterations for this, what will happen? Now 4 is common, and for t of n by 4 becomes 2t n by 4 divided by 2, n by 8 plus 2, and this 4 plus 2 is original. So we will be getting here 4 into 2, 8t n by 8 plus 4 into 8 plus 4 plus 2. So we are getting this, right? Now, when to stop this? Remember that when to stop this? So we can stop it when we are getting 2k divided by 2. Reason is 2k divided by 2, right? When you are talking about k minus 1 iterations, after k minus 1 iterations, what will happen, friend? It is, see here, first iterations, it is 2. Second iterations, 2 square. Third iterations, 2 cube. So can we write it, these whole statements as a 2 cube, right? If you wanted to write 2 cube t n by 2 cube plus 2 cube plus 2 square plus 2. Now we are talking after k minus 1 iterations. After k minus 1 iterations, k minus 1 iteration, what will happen? This can be written as 2k minus 1 t of, look, n divided by 2k minus 1 plus 2 power k minus 1, and it will go 2 cube, 2 square and plus 2. It is written here. Look, n divided by 2k minus 1, I have written here t of 2. That need to understand. So try to understand this. How we are getting t of 2? T of 2 from this n divided by 2k minus 1. So remember that n is what? N divided by 2k minus 1. N is what? N we have considered 2 power k. So can we write 2 power k divided by 2 power k minus 1, and simplify this, we will be getting t of 2. So that is we are getting t of 2. 2 of k minus 1 is can be written as 2 of power k divided by 2, hence 2 will go up and hence it is 2. So here 2 power k minus 1, and what is t of 2? If n is equal to 2, value is 1, hence it is 2 power k minus 1, multiply it, and other term is 2 power k minus 1 is as it is till 2 power 1. Now in order to simplify this, we are getting t of n, t of 2 power k minus 1, and this part we have to understand how you are going to write this from here. Okay, for that let me do it such a way that will be easier to understand. Now we are getting the equations t T of n is equal to 2 power k minus 1 plus 2 power k minus 1 plus 2 power 2 plus 2, right? Can we rewrite it? Yes, 2 power k minus 1 plus, just take this 2 square, 2 cube, so and so, 2 power k minus 1. Now in this particular case, from here to here, this is k minus 1 term and it is in GP, geometrical progressions. Hence, what is A? A is 2. What is R? R is 2. Next term divided by first term. 4 divided by 2 is 2. 8 divided by 4 is 2. Hence, common ratio is 2. This common ratio, this is the first term. In that case, sum of n term formula is A into R to the power n minus 1 divided by R minus 1. In this case, A is what? 2 into R is what? 2 power n. Number of element is k minus 1 minus 1 divided by 2 minus 1. If you simplify this, right, it is 2 into 2 power k minus 1 minus 1. This 2 minus 2 is 1, right? So we got this 2 into 2 power k minus 1 minus 1, right? If you simplify this, what will be that? 2 power k minus 1 into 2 power k minus 2, right? 2 power k minus 1 minus 2. Now let us see that in previous case, we have 2 power k minus 1, 2 into 2 k minus 1, we are getting 2 power k minus 1 and minus 2, right? Right? So final is T of n is equal to 2 power k plus 2 power k minus 1 minus 2. Do you have any common terms in this? Yes. What is that? 2 power k, 1 plus 1 by 2, right? And this is minus 2 as it is. So hence we are getting 2 power k into 3 by 2 minus 2. And what is this? 2 power k? 2 power k we have already considered as a n. Hence we can write it n. 3n divided by 2 minus 2. Right? 3n divided by 2 minus 2. In that case, we can say that this is our time complexity 3n divided by 2 minus 2. It is more than n. It is more than n, right? And we have some constant subtractions factor. So what we can conclude it here is, in this particular case, here also this time complexity belongs to theta of n categories, right? And what we have discussed in previous case, that time complexity also belongs to theta of n categories. So we don't have much benefit out of it, right? It is nearly same time complexity, right? Next we wanted to discuss is recursion tree along with this concept. Okay, how to deal with recursion trees and how to write the recursion trees for, say, as for example 10, 5, 20, 3, 8, 2. 10, 5, 20, 3, 8, 2. So number of element we have a 6 and array index 0, 1, 2, 3, 4, 5. It can be negative or positive, friends. Input can be negative or positive. We know that negative is having lesser magnitude. So in a negative, minus 20 is lesser than minus 2. So you need to keep it in mind, then you can do the min and max values. So if you are going to write that recursive tree, write it in a square, their L and R values. Okay, L and R. So if you are writing here in this case, what is L? Is 0. Low index. What is high index? Is 5. Right? Leave this place. Now we are going in left hand side. Left hand side we have low index, and here we are going to compare 0 plus 5 divided by 2 is 2. So 0 to 2. 0 to 2. So we have 0, 2. Right? Right hand side we have 3, 5. right? So what will happen, friend? It will go low j and high index low index. Look here, while you are writing the functions, what we have? L, R, max, mean. So we are going to write in 4 parameter. That is why I kept blank now. Okay. So we are going to write in same fashion. So 3, 5, right? We'll discuss this part. Again we are going to break it, right? So 0 plus 2 divided by 2 is 1. So 0 to 1, 0, 1, right? Right side will be just same element 2, 2. Low is same and high is same. Here low and mid plus 1, 1 plus 1 is 2, maximum is 2. Similarly here we have a 3 plus 5, 3 plus 5 divided by 2 is 4. So here we have 1 is 3, 4, and right will be, you can understand that 4 plus 1 is 5. So mean is low index 5, high index 5. Okay, 5 and 5. So as per our problem, 0, 1, 1 minus 1 is 0. Second case, 2 and 2, L and R is same. 3 and 4, low and high minus 1 is same. 3 and 3, and here. So this is the last positions where we don't have difference of more than more than one element. Either this is pointing to the same elements, this is pointing to the same element, these all are is having two elements. So if you have 2 elements, no need of calling recursive functions, it will be terminate from there. What I said, if one element, same element, only single element, will use this. If you have 2 elements, we'll use this. So single or 2 elements is there is no problem. We are not going to call the recursive function, hence we stopped it. Okay, let us see that now. If you have 0, 1, in 0, 1, which is maximum, which is minimum? 0, 1, 10 and 5 you are going to compare. 10 is maximum, 5 is minimum. So this is the first node, first iterations is completed. Here 2, 2, 2, 2, we have 20 is maximum, 20 is minimum, right? 3, 4, 3, 4, it is 8 is maximum, 3 is minimum, 3, 4, and 5, we have a 2 is maximum, 2 is minimum. Okay, so it is 1, these are second iterations, third, 4, 5 iterations. Done. Now we are going to compare this and this. 0 is low. In this side we have R and this is your final R. So basically this is mid and this is mid plus 1. So we are going to compare 0, 1, 2, 2. Now 10 is maximum, 20 is maximum. 10 and 20 we are going to compare. Which is maximum? Max and max right hand side. 10 and 20. 20 is maximum. 5 and 20. Which is minimum? 5 is minimum. So done with that. So this is the 6th iterations. Here, look, 3, 4, 5. So it will be 3, 5. 8 and 2. Which is maximum? 8 is maximum. 3 and 2. Which is minimum? 2 is minimum. Now here we have 0 index, 2 index, 3 index, 5 index. 2 plus 1 is 3. So 0 to 5, low index and high index. 20 and 8 you are going to compare. Which is maximum? 20 is maximum. 5 and 2 you are going to compare. Which is minimum? 2 is minimum. So here we got it, right? This will give you dividing part, and bottom of approach what we have applied now, that is after recursive call, how you are going to find out mean and max values. Hence this is called recursive tree. Recursion tree. Recursion tree for max mean algorithm. Okay, max mean algorithms. So sometimes they will ask you in the exams that write algorithm for max mean algorithm using divide and conquer. Divide its time complexity along with recursion trees. So sometimes they will ask recursion trees or recursive trees, right? So hence here we completed with divide and conquer all the algorithms. Thank you very much.